Okay, good morning, guys. You're going to be taking some notes today and finishing up the magnetic forces reading. So on Thursday, Friday last week, we started this reading. We did the first 2 pages. It's up to you guys today to finish up these notes. So what I want you to do right now is copy these notes into page 5 of your notebook. So we're going to start with the same topic, magnetic forces. Our essential question is still, how do magnetic fields interact? And then you're going to use the reading to answer these questions today. So I'm at home with my daughter. I'm trying to teach from afar today. You have 5 questions you're trying to answer. How can we see the magnetic field? How does a compass work? How does potential energy change with magnets? What is a magnetic domain? And then finally, what is the difference between a temporary magnet and a permanent magnet? So today you're going to find all of your answers in the magnetic forces reading that we started last week. So we stopped right here. And you guys are going to continue reading through the remainder of the pages, trying to find the answers. Okay, so for question 1, it says, how can we see the magnetic field? We're going to look for that answer right here. How can you model the force of a magnet? Magnets can repel or attract each other even when they are not touching. An invisible magnetic field surrounds all magnets. So this field is invisible. How do we see this invisible field? This magnetic field applies forces on other magnets and magnetic materials. This force applies even when magnetic material is not in contact with the magnet. Magnetic fields. When iron fillings are sprinkled around the bar, fillings form a pattern of curved lines that show the magnetic field. A magnet's magnetic field can be represented by lines called magnetic field lines. So we can see the magnetic field lines by dropping iron around them. The lines closest to the poles where the magnetic force is strongest, and the lines are farther apart where the force is weaker. Earth science connection. As shown below, a magnet surrounds Earth. Earth's magnetic field is due to molten iron and nickel in its outer core. Earth has a magnetic north and south pole. So this picture down here below shows us excuse me, the magnetic field lines. So these lines that you see kind of running around the magnet from north to south, these are the field lines. And notice it says they are closest together at the poles, and we see that in the picture. There are more lines kind of close together at the poles, and they're more spread out farther away from the magnet, and this is where the force is weaker. So I'm just going to show you how you're going to do your notes today. You're going to try to draw a picture in your notes. And again, always try to summarize what you wrote and put it in as short of an answer as possible. So how can we see the magnetic field? We can use iron fillings. We can use iron fillings or small pieces of iron to see the curved magnetic field lines. So now I'm going to just draw a magnet here because I think seeing this would make more sense. So I'm going to draw a north and a south pole on my magnet. Remove my image here. And I'm just going to draw some field lines. I'll change the color just so it's a little easier to see. Just kind of running from north to south. Okay. And so that's kind of how I want you to do the notes today. You're just going to kind of go through the book, find the answer, and summarize it. So let's look at number 2 here. How does a compass work? So you're going to go to the next page. And you're going to read this paragraph here. And you're going to try to summarize this paragraph for how a compass works. All right. The third question asks, how does potential energy work with magnets? You're going to find that right here on the third page. So use this paragraph to explain. I would draw this picture in your notes. That picture should help you visualize and see how magnetic potential energy will change. What is a magnetic domain? You're going to find that on the following page here. So you're going to put that definition down. What is a magnetic domain? And then lastly, what is the difference between a temporary and a permanent magnet? You should find that answer on the final slide there. Okay, now when you are all done today, you are going to upload a picture of your notes and turn them in for today. So on our calendar, the magnetic forces reading notes, this is your assignment that is due today. You're going to open up this Google Doc and take a picture of page 4 and now page 5 of your notes. Page 4 we did last week and page 5 you just did today. So insert a picture of your notes from last week on this slide. And on page 5, insert your notes for page 5. These were the questions that I gave you today. Okay. When you are all done with your notes, you have this magnetic fields Edpuzzle to do as your homework.